One particular example of exponential growth is something called compound interest, where you deposit some money in the bank, and then they pay you some interest, and then you earn interest on that interest, and interest on that interest, and so forth. And that's why your bank account balance doesn't grow linearly, but it grows in a bending upward way, like the exponential growth graphs that we saw earlier. Compound interest isn't that interesting for its own sake, but it's going to lead us to something that is quite interesting. So our first example, you're going to deposit $1,000 at 8%, what they call nominal. Nominal means in name. Nominal interest in a bank account. What is your balance? In other words, how much money do you have? After 1 year, you're not putting any more money in or taking any more money out. If the interest is compounded annually, meaning just at the end of the year, or quarterly, meaning every 3 months during the year. So if it's compounded annually, you're just going to take your $1,000, you're going to earn 8% on it. 8% of 1,000 will be $80. So you'll have earned $80 and you'll end up with $1,080. One way to write that is you took the 1,000 that you started with, you took 1 plus the 0.08, and then you just multiplied it by itself one time, and you ended up with $1,080 exactly at the end of the year. Now, if they pay quarterly, do we expect to have a balance of more than 1,080 or less than 1,080? We should expect to have more because now we're going to get the chance to earn interest on the interest that they pay us during the course of the year. Now, one thing that people sometimes don't realize is that when you're earning 8% nominal interest compounded quarterly, it doesn't mean they're paying you 8% every quarter. It means they're paying you 1/4 of 8% every quarter. So they're paying you 2% every quarter, meaning you start with $1,000, and in the first quarter you earn 2% of that. In other words, you earn $20. But then you've got $1,020 to earn interest on for the next quarter. So if we wanted to write that out as a formula, how did I get 2% as the amount that I earn in a quarter? I took my 8%, which is 0.08, and I hope you realize there's a big difference between writing 0.08 and writing 8. 8 would mean 800% interest. So if you're making up some sort of Excel spreadsheet, that's a common error that people make. We divided that by 4. That's how we got 2%. So you're multiplying by 1.02, but you're doing that 4 times during the course of the year, after a quarter, after another quarter, after another quarter, and at the end of the year. So it's 1.02 raised to the 4th power. And when we do that, we end up with $1,082.24, approximately. This doesn't work out to exactly that amount. So a little bit more, but is it really worth changing banks? Maybe not, just for the extra $2. Now, this is a more interesting example. Now you're depositing $1 million at 100% nominal interest. Now you might say 100% nominal interest, that's great. And there actually are places in the world where you can get 100% nominal interest, but it's not great. It's because these are places that have hyperinflation. The cost of goods is going up like more than 100% a year. So if you've ever seen pictures from the old days of people in Germany carrying wheelbarrows full of cash, of marks to buy bread and things like that, that's what happens when you can earn this sort of interest in a bank. So we don't really want to be in that situation. But to make the numbers work out to what we want to see, we're going to say this. $1 million, 100% nominal interest. How much will you have after 1 year if the interest is compounded n times per year? So very similar to this. So you're going to have the 1 million, 1 plus, so when it was 8%, we put 0.08, but now it's 100%, so 100% really means putting a 1 there. And if we were compounding it quarterly, we'd put a 4 down here, and what would this work out to be? It would be 1.25, meaning you're earning 25% a quarter, which makes perfect sense. That's what we would expect. But we're not told that it's quarterly, we're told that it's n times per year. So whatever n happens to be, so if you were compounding it 20 times a year, that would mean you're earning 5% during each of those compounding periods. But just as in this case, we earn the interest 4 times during the year, same thing here. So if we only compound it at the end of the year, n is 1, you earn 100% on your $1 million, and you have $2 million at the end of the year. The reason this question is interesting is what happens as n gets bigger and bigger and bigger. So what happens as n goes off to infinity? This is our symbol for infinity. We'll talk more about that in a later class. So this is our first example of a limit. We're going to see lots and lots of limits in calculus. We want to see what happens as n goes to infinity. We know that if we compound it 1 time a year, we're going to end up with $2 million. Based on what we saw over here, if we compound it more than 1 time per year, we're going to end up with more than $2 million. But the question is, as n goes to infinity, will the amount that you have at the end of the year also go to infinity? Will there be a way for you to earn $5 million, $6 million, $1 billion, $1 trillion by the end of the year? And we have an applet for you to experiment with different values of n to see what happens as n goes to infinity. So please go ahead and try that applet. Let n be as big as it can in the applet and see if, as n goes to infinity, whether this quantity ends up also going off, seems to go off towards infinity, or it seems like it will level off. Short and sweet.